Survival analysis is a statistical method used to analyze time-to-event data. It focuses on understanding how long it takes for a particular event to occur. This event could be anything from the time until a patient recovers from a disease to the lifespan of a machine component. Survival analysis helps us understand and predict the probability of these events happening over a period of time. This method is essential in many fields because it deals with situations where the timing of an event is crucial. By analyzing survival data, researchers can identify factors that influence the occurrence and timing of events. This knowledge is invaluable for making informed decisions, developing effective strategies, and improving outcomes in various domains. Survival analysis is particularly useful when dealing with data that is censored, meaning that the exact time of the event is unknown for some individuals or objects in the study. This is common in many real-world scenarios, making survival analysis a vital tool for researchers and practitioners. Several key concepts are central to survival analysis, each providing unique insights into the data being studied. The survival function, denoted as SET, represents the probability of an individual surviving beyond a specific time point, T. It provides a measure of the likelihood of experiencing the event of interest after a given time. The hazard function, denoted as HT, describes the instantaneous risk of experiencing the event at a particular time point, given that an individual has survived up to that time. It reflects the immediate likelihood of the event occurring and can vary over the study period. Censoring occurs when the event of interest is not observed for all individuals in the study. This could be due to various reasons, such as individuals dropping out of the study ending before the event occurs for everyone, or the event not occurring for some individuals within the study timeframe. Understanding these concepts is crucial for interpreting the results of a survival analysis and drawing meaningful conclusions from the data. They provide a framework for quantifying and analyzing time-to-event data, considering the unique challenges posed by censoring and time-varying risks. The applications of survival analysis span across diverse fields, highlighting its versatility and significance. In healthcare, it is widely used to analyze patient survival times, assess the effectiveness of different treatments, and identify risk factors associated with disease progression. For instance, researchers can use survival analysis to compare the effectiveness of two chemotherapy regimens in treating cancer, considering factors like tumor stage and patient age. In engineering, survival analysis plays a critical role in reliability analysis. It helps engineers estimate the lifespan of machines and components, predict failure times, and optimize maintenance schedules. For example, manufacturers can use survival analysis to determine the average time until failure for a specific car part, informing warranty policies and maintenance recommendations. Social scientists utilize survival analysis to study various social phenomena, such as unemployment duration, time to marriage, and divorce rates. By analyzing these events over time, researchers can gain insights into societal trends, economic factors, and individual behaviors. For example, sociologists might use survival analysis to investigate how education level and socioeconomic background influence the time it takes for individuals to find employment after graduation. These examples demonstrate the broad applicability of survival analysis in addressing real-world problems and answering critical questions across different disciplines. Its ability to handle time-to-event data, including censored observations, makes it an invaluable tool for researchers and practitioners alike. Survival analysis is a powerful statistical method that provides valuable insights into time-to-event data. Its ability to handle censored data, model time-varying risks, and quantify survival probabilities makes it an essential tool for understanding and predicting events of interest. From healthcare to engineering and social sciences, survival analysis plays a crucial role in advancing knowledge, improving decision-making, and optimizing outcomes. By analyzing survival data, we can identify risk factors, evaluate interventions, and gain a deeper understanding of complex processes that unfold over time. As we continue to collect and analyze vast amounts of data, survival analysis will remain an indispensable tool for researchers, practitioners, and anyone seeking to understand and predict events in a time-bound context. Its versatility and wide-ranging applications ensure its continued relevance in an increasingly data-driven world.